the temperature remains constant until all the liquid state will get converted into gaseous state. This is nothing but change in volume per unit volume per degree rise in temperature, which is nothing but the definition of coefficient of volume expansion. Specific heat of a gas at constant pressure to specific heat of a gas at constant volume, and it is denoted by gamma. Hello everyone, welcome to session 3 of chapter 11, Thermal Properties of Matter. This is Swati from Department of Physics, Vidyashram Pre University College, the Temple of Excellence, Mysuru. So in this chapter, as we all know, we are studying the properties of matter, that is, how does the matter behaves as the temperature is varying. So in today's session, first let us derive a relation between coefficient of volume expansion. It is given by alpha V of an ideal gas and absolute temperature. So alpha V is equal to 1 by T. This is what the derivation we are supposed to derive. The relation between coefficient of volume expansion and the absolute temperature is given by alpha V is equal to 1 by T. So let us now derive it with the help of ideal gas equation. What is ideal gas equation? That is PV is equal to RT. This is at temperature T. As we all know, as the temperature changes, say for example, if the temperature changes from T to delta T, there will be an increase or the change in volume that takes place to a considered gas. We can also observe a change in volume because as the temperature increases, the volume expansion in gases will take place, and this change in volume is given by delta V, which is equal to R into delta T, which means when the temperature varies, when the temperature increases, so increase in temperature is nothing but change in temperature. As the temperature changes, volume expansion will take place and hence the volume will also change. Now let us consider this as equation 1 and equation 2. Now for simplification purpose, let us divide equation 2 and 1. So what do we get? We get P into delta V divided by PV, which is equal to R into delta T divided by R into T. Here we can cancel P and P, R and R, and we remain with delta V by V equals delta T divided by T. Now I can bring this delta term to my LHS and we can write the same expression as delta V divided by, we have V in the denominator, so we am writing as it is. Delta T is in the numerator of RHS, so when it gets transferred to LHS, it will come to the denominator, so that is delta V by V into delta T, which is equal to 1 divided by T. Now look at the expression carefully. This is nothing but change in volume per unit volume per degree rise in temperature, which is nothing but the definition of coefficient of volume expansion, that is given by alpha V, which is equal to 1 by T, is what the relation between coefficient of volume expansion and the absolute temperature of an ideal gas. This is very important. For 3 more questions, we can expect this in the examination. So our next topic is heat capacity of a substance. So what does it mean? How to define it exactly? So the change in temperature of a substance when a given quantity of heat is absorbed or rejected by it is called as heat capacity of a substance, which means what is the amount of heat that a substance can absorb, or what is the amount of heat that a substance can reject into atmosphere. That gives us an idea about heat capacity of a particular substance. As the heading says, we are talking about the capacity of a substance, how much the heat can it absorb or it can release to the surrounding. That is called as heat capacity, and it is given by delta Q divided by delta T, amount of heat required to change the temperature of a substance, that is delta Q divided by delta T, where delta Q is change of heat and delta T is change in temperature. So if the heat capacity of a substance is clear to all of us, we can define the next important term, that is specific heat capacity of a substance. So what is the specific heat capacity? As the name says, the specific heat capacity means amount of heat that is required to raise a temperature of unit mass of a substance through 1 Kelvin. Here the mass is specified, that is unit mass of a substance through 1 Kelvin. We'll call it as specific heat capacity, and it is given by 1 divided by m into delta Q divided by delta T, because as we all know, heat capacity is just delta Q divided by delta T. Here we are talking about specific heat capacity, which means amount of heat required to raise the temperature of unit mass of a substance. So delta Q divided by m into delta T, where delta Q is change in heat and delta T is change in temperature. M is nothing but the mass of a substance, but the SI unit of specific heat capacity is joule per kg per Kelvin. So how do we get this? Q is nothing but the heat energy, the SI unit is joule, and mass SI unit is kg, temperature we have the SI unit is Kelvin. When these two quantities transposed to a numerator, we will get joule per kg per Kelvin is the SI unit of specific heat capacity. So this specific heat capacity depends on the nature of a substance and its temperature. Suppose if we want to denote the specific heat capacity with number of moles, then we can write it as 1 by mu into delta Q divided by delta T, where mu is nothing but the number of moles, and in this case the SI unit will be joule per mole per Kelvin, since we are denoting or we have considered the substance in terms of number of moles, and here C is nothing but the molar specific heat capacity of a substance and mu is nothing but the number of moles. Molar specific heat capacity is nothing but the amount of heat that is required to raise the temperature of 1 mole of a substance through 1 Kelvin. It is given by the relation C is equal to delta Q divided by mu into delta T, and the SI unit is joule per mole per Kelvin. So now we came to know what is heat capacity, what is specific heat capacity, what is molar specific heat capacity. So if the gas is held under constant pressure during the transfer of heat, then we will call it as molar specific heat capacity at constant pressure, and it is denoted by Cp. Or if the gas is maintained at a constant volume during the heat transfer, then the molar specific heat capacity is called as molar specific heat capacity at constant volume, and it is denoted by Cv. Here Cp is molar specific heat capacity at constant pressure and Cv is molar specific heat at constant volume. There is a relation between these two variables, that is Cp minus Cv, which is equal to R, and it is called as Mayer's equation. So Cp minus Cv is nothing but the difference in molar specific capacity at constant pressure and molar specific heat capacity at constant volume, which is equal to R, and this is called as Mayer's equation. So we are talking about the specific heats, that is molar specific heats, that is at constant pressure and constant volume, and we denote them as Cp and Cv respectively. And our next concept is ratio of specific heats. What is the significance of ratio of specific heats? Why we have to study that? There is an important significance. Before that, let us know what is ratio of specific heats. It is defined as the ratio of specific heat of a gas at constant pressure to specific heat of a gas at constant volume, and it is denoted by gamma. So gamma is nothing but ratio of specific heats, that is Cp divided by Cv. So the significance or the importance of this ratio of specific heats is nothing but the value of this, or the knowledge of gamma helps us in understanding the molecular structure of the gas, which means the number of atoms are present in a molecule. The idea of this we can get by the help of the ratio of specific heat values. That is, if gamma value is so much, we can say that the gas is monoatomic. If the gamma value is so much, we will say the given gases are diatomic or triatomic, like that. So about this ratio of specific heat capacities, we will study more in detail in the chapter called kinetic theory of gases. So let us now discuss about some practical application of this specific heat concept in our daily life. Example, when compared to other substances, water has highest specific heat capacity and its value is 4186 joule per kg per Kelvin. And this is the reason why we use water as coolant in radiators and heaters in hot bags, because water has got all the special properties in the nature. It has got the anomalous expansion behavior. Also, it has got the highest specific heat capacity, and the reason why we use only water as coolant in radiators, because the specific heat capacity of water is more. So our next topic is calorimetry. So what is the meaning of calorimetry? Metry means measurement. So calorie means it is a energies unit. So what kind of energy we are measuring here? That is nothing but heat. So calorimetry means measurement of heat. So here, when a body at high temperature, suppose if you consider two bodies, say for example I have two bodies, one body is with high temperature, the other body is at which low temperature. When these two bodies are brought in contact with each other, what happens generally? Generally, the transfer of heat takes place from a body of higher temperature to a body of lower temperature. So until they attain the equilibrium condition, the heat transfer will takes place. So what is the amount of heat that a body of higher temperature loses? The same amount of heat the body at lower temperature will gain, and this mechanism is called as conservation of energy. So calorimetry or calorimeter is a device which we use to measure the heat, and the device which works on the principle of conservation of energy, that is nothing but heat lost by the hot substance is equal to heat gained by the cold substance. So when a body at high temperature is brought in contact with another body at low temperature, the heat lost by the body is equal to heat gained by the another body which is at lower temperature, provided no heat is allowed to escape to the surroundings. It will be completely insulated. So a device which is used for the heat measurement is called calorimeter, as I said. See here, this is a schematic representation of calorimeter. Basically, this is nothing but the wooden jacket, in which inside the wooden jacket we can place a calorimeter, which is nothing but object which is made up of certain metal, which will be provided with two holes on the top of it. One is to insert a thermometer, the other one is to insert a stirrer. So here this gap is completely insulated by insulating material, making sure that the no heat is getting escape into the surroundings. The principle of calorimeter is, as I said, it works on the principle of heat gained by the cold body is equal to the heat lost by a hot body, or we can simply write heat gained by the body is equal to heat lost. So let us briefly study about the calorimeter. As I said, it is nothing but a metallic vessel. Calorimeter is basically a metallic vessel, and it consists of a stirrer of the same material, say for example copper or aluminum, etc. So this vessel is kept inside a wooden jacket. Say for example, if this is a calorimeter, it is kept inside the wooden jacket, and it contains, as I explained, insulating material within it, because to avoid the heat energy to get escape into the surroundings. And the outer jacket acts as a shield. Shield means it will again acts like a shield just to cover the energy not to escape into the outside region, and it reduces the heat loss from the inner vessel. There is an opening in the outer jacket through which the thermometer and the stirrer can be inserted. So this is the basic formation or the structure of calorimeter. So what is the question that you can expect from this concept is, what is the principle of calorimeter, or on what principle does the calorimeter works? So it works on the principle of conservation of energy, that is heat lost by a body is equal to heat gained. So our next concept is change of state. This is not at all a new or a strange topic to all of us. We all know what is change of state. By taking an example of ice, ice to water, water to vapor, we have almost studied these concepts since childhood. See, again, we are going to study the same concept, that is change of state. From this graph, we can observe, we can know a simple and important concept, that the temperature remains constant during a substance which is changing its state from one form to another form. Here I have a graphical curve of a substance called ice and or water, and the graph is along x-axis it is time and along y-axis it is temperature. From this we can observe at 0 degree Celsius, as we all know, it starts melting. So below 0 degree Celsius it will be in its solid state. So at 0 degree it starts melting lightly. As the temperature increases and increases, the whole ice will convert into liquid. Here it is a state of liquid. So in this process you can observe the temperature remains constant until the whole ice will convert into liquid. Again, to convert liquid into gas form, there must be an increase in temperature. As the temperature increases, later the liquid will start boiling and it will convert into gas. So, the temperature remains constant until all the liquid state will get converted into gaseous state, and this is called as boiling point. This is melting point. Boiling point is what? Both the liquid and gaseous states coexist, because as we all have observed, when the water starts boiling, there will be an existence of water as well as vapor, and that point is called as boiling point, where we can observe both the states of matter, that is liquid and gas. Similarly, melting point you can observe ice starts melting, which means liquid state will also exist as well as the solid, that is ice, will also be there when it starts melted. So the point at which both solid and liquid states coexist, we'll call it as melting point. The point at which both liquid and gaseous states coexist, we'll call it as boiling point. So the temperature remains constant until the whole water will get converted into gas. So this is what the temperature curve for a change of state. To understand the behavior of the matter, how does it changes as the temperature increases, and when will the temperature remains constant. So the process of changing the state of matter from solid to liquid is called as melting, and the change of state from liquid to solid is called as fusion. The change of state from liquid to vapor is called as vaporization. As we all know, the solid state will get converted into liquid state, and we will call it as melting, and converting the change of state from liquid to solid, vice versa, that is fusion. The change of state from liquid to vapor is called as vaporization. So what is melting point? As I said, the temperature at which both solid and liquid states will coexist, we'll call it as melting point. Melting point of a substance decreases with increase in pressure. And the next is regelation. Since we are talking about the properties of matter, knowing about regelation is very important. Regelation is nothing but the process of refreezing. Where can we observe this process called refreezing? When pressure is applied to block of ice, what happens? It melts. It melts due to decrease in the melting point, because as we all know, melting point is inversely proportional to pressure. So when the pressure is released, melting point increases and the ice refreezes. This phenomenon is called as regelation. This is the property which is responsible for the skating. Whenever the skater is applying pressure on an ice, the ice starts melting and there will be a formation of water which helps the skater to slide over. As he slides further, the space or the region where he stood before will again refreeze, and hence we can never find water as we move on during skating. So it's possible due to the regelation property of ice. So this is all about melting point, and the boiling point is nothing but the temperature at which both the liquid and vapor states coexist, and the boiling point increases with increase in pressure, which means it is directly proportional to pressure. That is the reason why the cooking is so easy in pressure cooker, because in pressure cooker there will be more pressure, and that is the reason why we can cook more easily with the help of pressure cooker. And at the same time, the cooking is so difficult at high altitudes like on mountain regions, because the pressure will be less. So this is nothing but the boiling point and the melting point we have studied till now. So next concept is sublimation. What is sublimation? It is nothing but the change of state from solid to vapor directly without passing through a liquid state. And for best example to understand the sublimation is a camphor. As we light up the camphor, we can observe the vapor state from solid directly without undergoing liquid state, and also dry ice, iodine, etc. are the examples we can study under sublimation. So next is the phase diagram, which is important again. So the graph between temperature and pressure of the substance is called as a phase diagram or PT diagram. You can observe here along y-axis we are varying pressure, along x-axis it is temperature. So here in this graph you can observe OA is nothing but the sublimation curve, because solid state and vapor state coexist, or it is represented by a curve OA, and AB is the fusion curve. Fusion is nothing but liquid to solid. So it is fusion curve. Solid and liquid phase coexist during this process, that is under the curve AB, and AC is the vaporization curve. It represents the state of liquid and vapor phases coexistence. So the temperature and pressure at which the fusion curve, vaporization curve. So the temperature and pressure at which all this fusion curve, sublimation curve and vapor curve meets, and all these three states coexist, is called as triple point of the substance. So it is called as triple point, where all three curves meet, which means all three states of matter coexist. We'll call it as triple point. So the significance of phase diagram is we can know the triple point of a substance by plotting a curve of pressure versus temperature of a substance. So in this session we have learnt about so many properties, and we have discussed about the basic laws or basic observation during the change of state and the terms related to change of state, regelation concept and a phase diagram. In our upcoming session we will have a discussion of some more interesting concepts. Until then, keep learning all of you. Thank you.